Hello my friends, welcome again to my video channel. Today we continue our work on the Kenwood TS700S line, and as I promised you at the end of part 6, much more alignment will come. So let's start. First is the adjustment of the SSB sensitivity on the generator unit. There are some filters which have to be aligned for maximum. The scheme here proposes to measure the output voltage of the receiver with a dummy resistor on the loudspeaker output. This is a possibility, but I think it's not a good idea because we have the problem that the AGC, the automatic gain control, always works. So I think it's simpler to use the S-meter here as an indication for maximum. It's not important whether it's accurate or not. It is not accurate, but it's good enough for a maximum indication. And I have the signal connected 144.500, 144.500, and this is the signal we can hear. It is roughly 1 microvolt, a little bit less, and then there are 3 cores which have to be aligned for maximum. And we can see this one was for maximum. It's T4, T5 and T6. This was not maximum here, you see. I didn't align it before. I only check it, and this one is behind the harness. That's very clever again. There is a big harness across over the core. How to get through this harness. Okay, not okay. This is maximum now. What have I done? It's simply an operator too stupid error. I misaligned the core. I slipped off the slot and misaligned it. So now I can align it to maximum. It's a little bit difficult because the harness blocking me. I have to open the harness. I reduced the input signal a little bit, but now I have better access. Then I can align it for maximum. Much easier. This core is a little bit touchy, don't know why. Okay, and repeat the others again. The first one also. That's it. Adjustment of S-meter. Start level. It has to be checked first. Node USB. It's okay. The RF gain control fully counterclockwise, then the S-meter is fully deflected, it's okay. And when the RF gain is clockwise, minimum is indicated, that's okay. And then we should set VR4 on the RX noise blanket unit just before the point of beginning to deflect the S-meter with no signal applied. We have no signal in the input. And VR4, again I have to look at the new RX unit. VR4 is this vertical trim pot between the two others. Now I have to look for it. There are also a lot of cables between, but I think we can get access, but not with this. We need the right screwdriver, and I have to look for the point where the S-meter just starts. Just before the point. Okay. That's the point. That's it. Adjustment of the RX noise blanker unit. That's this part. The IF unit has to be unmounted. The signal generator should be set to an output signal. Now we have 10 microvolt as wanted here, but for an indication of 3 to 5. A bit too much. That's it. And then I should adjust T1, T4, and I look T1, T4, T5, 6, T7 does not exist on the new unit. This is deleted. And T8, sorry, not T8, T1, 4, 5 and 6. 1, 4, 5 and 6. These 4 cores I have to align for maximum indication. These cores have an hexagonal slot. It's not a slot, it's a hole, hexagonal. So I need such an alignment tool. Okay, I think it's a little bit better. I can use it and now align this. I'm on the 144.500, drive is set to 500, that's important. And now set it to maximum. This. This. Minor changes. Then I repeat it again. Next step is to verify that the drive control is maximum with center at 500 according to the frequency indication, and we can see left side, center, right side. So now the 500 is the maximum and it is peaked as required. Then next step is align T9 through T13, 9, 10, 11, 12, 13 for maximum at the same frequency, 144.500, drive again centered. I will do this. I think there is no much to be aligned. Can't imagine that something. Okay, a little bit. That's always minimum. Okay, there was some improvement. I can't say improvement. Really no improvement. I repeat it from beginning to the end. And now the signal generator is set to 145.500, also the transceiver here 145. And then there is a trim pot on this switch. It is VR11, and this has to be aligned that the S-meter again shows maximum. This is the correction of the tuning voltage for the cap diodes in the receive path when we switch from 144 to 145. And again, then the drive is centered. We can see that the middle 500 is identical. Now the signal generator is set to 144.900. That means 600 kilohertz down. And when I go to reverse, again we have the signal. We can hear it. And there's a second pot nearby on the same board. And now we have again the centered position. This is the river. Correct. Okay, there is no big difference, but this corrects the shift in case of repeater operation, so that we have a correct receive setting here also when we have shift operation with the repeater shift, that the RX is shifted 600 kHz down and the diodes, the cap diodes, are also tuned properly. And now we adjust the signal generator to 145.0 and also adjust the transceiver to this frequency. I have to switch the repeater, of course, off. I think I should stop now. It's late in the evening. I'm starting to make mistakes. Not so good. That's the last topic today for this evening. 145. And there's one T8 for maximum. Up to now we didn't align it. Where is T8? T8 is this one. Luckily T8 is not sealed with any white color or wax or so. And now for maximum. Okay, there was a little bit an improvement possible, but not relevant, not important. When we have such a big S-meter deflection, the receiver sensitivity is not affected by the setting of such a core. The noise figure is determined by the preamplifier in the first stage and not any IF stage or so. Adjustment of the noise blanket circuit. There are 3 cores, 3 transformers which have to be aligned. There's a test point, test point 2. I connected a voltmeter. Full scale is 10 volt. We have 4 volt. The signal generator 145.500 has to be increased from 0 until the voltage drops. This point is reached, and then the filter should be aligned for minimum voltage. That's the AGC voltage. And then I will start with the first core. Wrong direction. Not very effective. The second is better. There is some reaction. And the third one also. I'll repeat the other ones again. Okay, this core is rather at its limit, but it's a rather highly damped core or circuit, so it's not relevant. So the noise blanker circuit is also aligned. Now it's stated connect the noise generator to the antenna terminal. I will do it not in the moment. I will do it when I'm completely ready with the transceiver and check. And I will have to think about what a noise generator is. I have an idea using a square wave generator with a repetition rate of 1 Hertz or so, but not in the moment. Step 25, adjustment of the MCF. It's what is monolithic crystal filter. The mode is FM. Signal is connected with 1 kHz and 5 kHz deviation. We can hear it. The receiver is adjusted to the maximum, and then 2 filters T9 and T10, which are located directly between or near the crystal filter, have to be aligned for maximum. We already aligned them, but now they have to be realigned for maximum. Okay, I think it is. And when you tune across the signal, okay, there are 2 peaks, maybe caused by the modulation frequency. Let's switch modulation off. There's only 1 peak. Okay, exactly at 500. And with the modulation there's several peaks, of course, because the FM signal is rather broad with 5 kHz deviation and 1 kHz modulation frequency. I go down with the deviation to 2.5 kHz. Same effect, there are several peaks. But I think it's now symmetrical, that's important. Step 26, adjustment of discriminator unit. There are 2 coils which have to be adjusted, T3 and T4. The input signal has 3 microvolt. 1 kHz modulation frequency and FM deviation 5 kHz, and these 2 cores have to be aligned for best sine wave and for maximum output. And we can see it is already okay, but the shape of the output is not a perfect sine wave. We can align it. I think it is good enough for this purpose, and it will be adjusted a little bit later again with the center adjustment, but now I can leave it. When I reduce the input level to 1 microvolt, we see the signal gets a little bit noisy. This is 1 microvolt input signal, not very strong. When I reduce it further, we see the noise. So this makes no sense. Okay, step 26 is done. Step 27, adjustment of S-meter. Input signal should be 1 microvolt. It's not stated in which mode. I've chosen USB, but when I go to FM, there's no big difference. I will see whether there's a difference between FM and SSB. Anyhow, I've chosen USB. 1 microvolt input. VFO for maximum. Deflection on 500, okay. 1.5, 1.6 below, that's okay for USB. In LSB, it jumps to 1.4, 1.5 for That's okay. The amplitude indication is the same. And now adjust VR4 AGC sensitivity for a reading of 1 on the S-meter. VR4 is this one. Sorry, you can't see it. Now you can see it better. This is the same pot we adjusted some steps before for nearly zero reading without input signal. When I detune it, okay, it is 0. When I come back to the signal, 8.5, and then go to 10 microvolt and adjust VR2 for S9. VR2 is this one, should be adjusted for S9. Oh, come on. Oh, cannot be adjusted for S9. As we have seen, and I tried it with several attempts, that I was not able to align the S-meter to S9 with an input signal of 10 microvolt. The AGC line is this one, goes to this is the IF section, noise blanker IF section, goes to the transistors with higher input voltage, higher signal, this AGC voltage drops, and then this transistor gets less conductive, so this voltage here drops, and this transistor gets more conductive because the emitter here is clamped with VR4 at the 0 setting position, and then it should draw more current here through this and through the switch into the meter, but it doesn't work. First thing I saw after some investigations of the circuit, we have here a solid ground to grounding of the AGC line. Can't be. It works, so this is maybe a misdrawing, and this is the new TS700S. That's the board I have in my transceiver. When we compare it with the old one, with the old TS700S, no SP, what we have here, then we see the original circuit was the AGC comes in and is fed via this switch and this transistor here and another transistor to the S-meter, and the AGC is not tapped here, it's fed directly, and this line is still existing with this drawing, but the scheme was changed, so we have here the grounding, which is okay because the meter, the negative pole, is connected to ground or to center, which is a switch between center and S-meter for FM. That's okay, but this connection should have been deleted, but that's not the problem. A more thorough look into the schematic shows some errors. R32 150K. Here's another R32 150K. This cannot be true because we have here only 500 ohms. So the emitter resistor cannot be 150K. And when we have a look into the other schematic of the old TS700S, we see here in the R34 with 470 ohms. And the R32 here has only 100K, and the trimmer in series 500 kilo ohm. And here we have 500K with 150K in series. Okay, there's a different circuit, of course, but this is not true. And when we have a look into the board layout, then we have at Q6, in the emitter of Q6, indeed 470 ohm. So the circuit is wrong. So this one here is wrong. It should be this one, 470 ohms. And I checked it in the board. Indeed, we have here 470 ohms, and this is 150k, and this is 500k. So this is a wrong drawing, but the board is okay, and as I have seen, the resistor is also okay according to the color code. I will check these resistors and see what's going on. Maybe some of the resistors drifted away, but this trim port here is set to minimum value, so it is shorted, and still 150k is too big and cannot drive the full current through the S-meter. So something is wrong here in this circuit. First step, I will try to bridge this resistor, the 150k, with another 150k with this short clip leads, 150k wire pin and the other pin, and try to shorten it on the board. It's difficult to get access to it, it's very narrow, but I think I will be successful. Let's try it. I'm using 150k to bridge the other 150k resistor, and you see, okay, there's not so much. Difficult. It's nearly impossible to get a contact on this board here. It's so narrow. Okay, this S7, not so much. I have to decrease the resistor. Now I'm using 15k. Okay, we see much more than S10, S9. So the result is clear. We should replace the 150 kilo ohm resistor by a 15k resistor, and then we can adjust it. So I have to take out the RX noise blanker board and swap the resistor, and when I do this I measure the old ones, maybe some drifted away or so, or bad solder connections on the PCB, we will see. The RX NB board is out again. Here we can see the relay we repaired during the repair of the preamplifier, and here we can see the 3 pins of the pot, and from here to here, a little bit difficult to show it on the video, we can see the resistor, the R32, which has 150k, which is this resistor, and which I will here change to 15k, from 150 to 15k, and then hopefully the S-meter can be adjusted. The transistor here is replaced, the 150k. I didn't replace it with 15k, I used 1k5 because with 15k I was at the limit of the setting range of this pot, so I reduced it to 1k5. We could also use a jumper. A resistor is not necessary here because the current limitation is done with this resistance combination here, so it's not relevant whether here is 1k or not, or 0k case. This is 470 ohm, as we have seen. It's an error in the schematic. That's it, and I can show you now the result. Now we have an input signal of 10 microvolt. We nearly have S9. I didn't fully adjust it to S9 because the S-meter is rather non-linear. 1 microvolt. 1 microvolt is a little bit more than S1, so I've chosen a compromise. It's not possible to align it perfectly, and there's also some thermal drift I've seen. So this S-meter is not a voltmeter. It's only an indication that there is a signal, and the whole curve does look like this. The manual shows an example, whatever it means, an example. It's not a specified characteristic between 1 microvolt and 10 microvolt. The black one is the curve what should be, and the red one is what I have achieved what I got with my modification. It's rather precise at S9, a little bit too less. Here's a little bit too high at S1, S9. But a bigger deviation we have at the higher level, S1 plus 20 dB should be 100 microvolt. It's true. It's 10 times voltage. 100 microvolt is 10 times, that means 20 dB more power. There should be 100 microvolt. I only have measured it with 50 microvolt. And S9 plus 40 dB, which should be in the range of 1 millivolt or 1.4 millivolt, I found with 200 microvolt. So we see here the curve is much too steep. It should be more flat. It gets more steep. This is not as here specified, but it's not a specification, it's only an example. Well, better we can't do it, but it's important that S9 is rather precise, an input signal of 10 microvolt. That's important. Step 28, adjustment of the center meter. This instrument has also the option to show the center indication in mode FM. So we have to choose FM. It is set to FM. Then center meter. And we can see the pointer move to the center. We have no signal, no input signal. And the center meter terminal of the FM unit has to be grounded. I will do it now. With the clip lead. And there is a pot VR1 on the RX noise blanker board. And this has to be centered, so that the indication is centered. We see we can adjust it. And I turn it to my best view. One moment. So rather touchy sensitive. Okay. Remove the clip lead. That was easy. And now short the cathode of two diodes. It is stated D15 and D16. That's wrong. It's D9 and D10 is stated here. These diodes are generating a sort of threshold in the discriminator. So it is sufficient to connect them with a clip lead. Not more. Adjust T4 of FMIF, T4 is this one, so that we again have center. And you see when I detune it, and again we are centered. And now adjust T3 for maximum AF output. I think that's okay. It's the same setting as we had for best sine wave, for best demodulation. And now set the signal generator to 10 microvolt and connect it to the input. I will do it. Now a signal is tuned in and it has to be checked. 145.500. Ten microvolt. Turn the VFO to deflector meter to the positive side. We are getting indication 6, 7. Okay, that's it. Adjust VR1 on FMIF. This one to get a little bit bigger deflection. Up to the 8. And on the other side, it is stated it should be 2. Well, I have to give a little bit more deviation. Okay, that's it. Okay, now we have between 8, 5 is center, Is it centered? Yes, it is centered. And 2 on the other hand, on the other side. Okay, that's it. Step 29, adjustment of the receiver preamp. Mode USB on frequency 145.00. It is set to 0. A weak signal, 0.3 microvolt, unmodulated at the input, 145 megahertz. The RX or RDX switch is on. That's the difference between on and off. 1 volt, 0.63 volt at the loudspeaker impedance. And T2 and T3 of the preamp have to be set to maximum. Okay, you can see here is a maximum. No big difference. Set the RTX switch to off, and then we adjust for 0.63 volt again. It was not necessary before. And now with the switch on, 0.89 volt. Okay, a little bit too much. I have to reduce it with VR5. Where is VR5? And VR5 is this one. Oh my god, it was difficult to get achieve it. Okay, I can't reduce it, doesn't matter. 9.2. When I switch it off, 0.634, a little bit too much. I reduce it here to 0.63. 0.9. That's okay also. And now checking the operation of the preamplifier. Again, we are at 145 megahertz. Signal is 0.25 microvolt. The switch is off. The preamplifier is off. I reduced the RF gain a little bit, so we have an S-meter deflection. This is caused by the RF gain. I did this test before and I had problems with the AGC, which acted at this low voltage a little bit. So I take it out. Now I receive the signal. You can see it on the scope with maximum amplitude. I set it to 0 dB. Oops, a little bit too much. And then I take off the signal. And we have minus 19 dB. So the signal to noise ratio, or more precise, signal plus noise to noise is 19 dB. And then I switch the RDX on. Of course, we have more output. I reduce the gain of the audio frequency stage. And when I now take away the signal, it is 20 dB down. So the difference is roughly 1 dB. And here it is specified that the signal to noise ratio is improved more than 0.5 dB. Okay, it is. The preamplifier is not very useful. I think I talked about it. Bring back the signal. We are again at 0. And with RDX off, I'll do the same test again. And now signal away, minus 19. Well, that's done. The preamp works, but again, it's not a miracle. And now I do the same test with a 0.1 microvolt signal. First without preamp, set to 0 dB output with signal. It's getting rather noisy. And then I remove the input signal. So we have rather exactly 10 dB down. It's only noise. And this is signal plus noise. And then I switch on the RTX, remove the AF output again to 0. And then remove the signal, goes down to -11. Go back to the signal. Okay, it's not perfectly centered at 0 dB. That's it. And now -10, -11, yes. Also 1 dB down, the same result with a smaller signal. And now a short acoustical impression. And now we have the signal 0.1 microvolt on the speaker without preamp and with preamp. So you can hear the noise also increases. The effect of this preamp is not very big. And now I can't believe the adjustment is ready. There's only one item left. Check of the bandpass filter characteristic. It's the output filter. We have it. It's located on this side here. This copper box is the output filter. Here's the antenna connector. Here's the input. This cannot be aligned, but it should be checked. But for this purpose I will use a sweeper. I will take my nano NVA network vector analyzer, which is good for this purpose, a small box, and I will try to check this bandpass filter with it. The proposal here is to use a signal generator, stabilized signal generator, bandpass filter, and then to use a spectrum analyzer or field meter, and then to manually change the frequency and check the characteristic. Okay, but it can be done a little bit better with the sweeper. One item I will do, here's a hole. This is a tune capacitor to set the output voltage. I will seal it now with a self-adhesive aluminum strip to protect it. There should no dust or any other particles fall into it, because here we have the variable capacitor. It's a very sensitive, mechanically and electrically sensitive unit, so I will close this hole now. The hole is closed, protected. That's it. Next step, before I do the measurement here with the bandpass filter, I will fix now all cores with wax and to secure them, and I will use wax so it's possible to open it later and to realignment if it's necessary during any repair. I don't use any paint or so, only wax. That's enough. This is the end of part 7 of the videos about the TS700S line. In the next part we will do the final work, some cosmetic work, focus on the VFO 700, on the external VFO, do some work on the loudspeaker if necessary, and do some final measurements such as real output power setting and the spectrum in AM mode. I'm a little bit curious about the spectrum, how good it is or how bad it is. I fear it is bad, that the signal is rather broad in AM because there is no filter in the AM mode. That's not so good. Stay tuned, stay healthy, see you on this channel.